Hello, I'm Todd Spatafor, and this is another spectacular thing. So far, we've installed Gitea and Grafana as well as Prometheus in our cluster, and we can get to these using port forwarding. But that's not really the Kubernetes way. To set up port forwarding and have the ports memorized, and then you use localhost on your local machine. Realistically, what we want to do is put a real domain in front of this, and that's what we're going to do today. No port numbers, no terminal babysitting. If we forget and we close the terminal, then it'll still work. uh, and today we're going to to do that, we're going to add two layers. MetalLB for a load balancing IP network, gives us real IPs on bare metal, and Traefik. Traefik will act as our reverse proxy and our ingress controller. Um, so the end state will be http://get_t.spectacularly.xyz and http://grafana.spectacularly.xyz from any machine on my network, and it'll work. Let's take another look at this problem. We have to have two terminals open, one for Gitea and one for Grafana. This is fine for debugging, but that's not how services are meant to be exposed. What we actually need is a stable IP address for cluster traffic and a way to route by hostname, not port. Why does MetalLB exist? Well, cloud providers give you a load balancer automatically. On bare metal, nothing assigns those IP addresses. MetalLB fills that gap. MetalLB responds to ARP requests for IPs in your pool. The IPs live in the same subnet as your nodes. MetalLB just claims them. Simple, no BGP router required. Perfect for home labs. Your MetalLB pool must be on the same subnet as your nodes, not already assigned to any device, and outside of your DHCP range. So we're going to go ahead and install MetalLB via Helm with the Helm repo add MetalLB command. And then we're going to do MetalHelm repo update to update our repositories. And then we're going to go ahead and install MetalLB. You'll remember in video 4 we had to do a PSS fix to get Grafana or Prometheus to work. We need to do the same fix here on MetalLB. So we're going to go ahead and get pods and see the problem that's going on. Here you can see get isn't a command because I didn't do kubectl. kubectl get pods, not just get pods, sorry. And here you only see the MetalLB controller, none of the speaker pods. There should be 6 speaker pods here. The controller speaks to the speaker pods, and there's one speaker for each of the nodes in the system. So let's see what's going on. Let's do a kubectl describe daemonset MetalLB speaker and see what happens. And you will see, once I type this in, you'll see that there's a violate pod security baseline latest in here. So let's go ahead and do the Talos edit machine config and add an exemption for our MetalLB system namespace, just like we did in video 4. And then we want to restart the control plane. Talos does this every time a workload needs elevated privileges, and that's the point. Node exporter needed host access. MetalLB's speaker needs raw network access. Same fix, same reason. You're explicitly opting into each privilege. Once you've done it a few times, it's muscle memory. And here you can see that all 6 speakers are now available. Once all 6 speakers have started up, let's go ahead and configure our iPool let's configure our IP pool with an MetalLB-pool.yaml file. And in here you can see that we have addresses from 10.51.50.210 through 10.51.50.219. So we have 10 addresses that we're specifying for MetalLB. Once we save that, we'll go ahead and apply it to using kubectl apply-f MetalLB-pool. We have 10 IPs reserved here. For this video, we only need one of them. Traefik gets it and routes everything, but the pool is there as the cluster grows. Once that's finished, let's go ahead and sanity check. We'll verify MetalLB before touching Traefik. To do that, we're going to use this test load balance application that we're just going to spin up. We'll go ahead and save this, and we'll go ahead and apply it as well. kubectl apply-f testlb.yaml. Then we'll do kubectl get service testlb to see what we've got. We'll want to watch for our IP from our pool in the external IP column. And you can see here that we got 210. All right, our load balancer is working. Then we'll clean it up with kubectl delete-f test-lb.yaml. This 30-second check saves you from spending an hour debugging Traefik when the real problem is MetalLB never worked in the first place. Next, let's install Traefik, the Ingress controller. What is an Ingress controller? Well, an Ingress controller is a pod running inside the cluster that watches for incoming resources and programs itself to route traffic accordingly. MetalLB gives it one IP. Traefik decides where every request goes based on hostname. Why do we use Traefik for homelabs? Well, it has a built-in dashboard for visual proof that it's working, has dynamic config, and it installs cleanly via Helm. To install it, first we need to add the repo to Helm with this command. And then we want to update the repo with Helm repo update. We want to create a Traefik-values.yaml file with some values in it for our Traefik instance. Those include type load balancer, ingress class enabled, ingress route enabled, and then the API dashboard is true with the insecure is true. This enables the dashboard on port 9000 without TLS, acceptable for an internal admin tool that is kept behind a port forward. Next, we use Helm to install Traefik. We create a namespace, and that namespace is Traefik, and we use the values file that we just created. Then, just like we did with the load balancer test, we want to verify that it got a load balancer IP address from MetalLB pool. That's with kubectl get service -n Traefik, and you can see here that the external IP address is .210. Next, we're going to port forward port 9000 so we can look at this dashboard. But you might be wondering, we just said port forwarding is dead, and here we are port forwarding the Traefik dashboard. That's intentional. Gitea and Grafana are user-facing services that need to be accessible from anywhere on the network. The Traefik dashboard is an admin tool. It exposes your entire routing configuration to whoever can reach it. You don't expose that without authentication. For now, a port forward is exactly the right call. It means the dashboard is only accessible when you explicitly open a tunnel. We'll expose admin interfaces properly with authentication in a future video. And here's the dashboard. Isn't it pretty? We don't have any routes yet, so let's go ahead and add some routes into the system so that we have something to look at on this dashboard. Before we do that, we need to set up DNS. I use bind 9 on my local network, so I'm going to set up a domain spitacli.xyz to point to our .210 address. We do that by setting up the named-config file and creating a new zone for spitacli.xyz. Oops, I guess I don't have NVIM on here. Sorry. Anyway, so here you can see the zone for spatakly.xyz, and it's going to be defined in a file called spatakly-xyz.conf. And let's look at that file now. -xyz.conf .zone. Now this .zone file, it starts with the origin of spatakly.xyz. It has some serial refresh, retry, expire, minimum values, and then we have a wildcard here pointing to .210. Now we need to restart the Docker container that hosts my DNS server. And that's just Docker compose restart. Now let's go ahead and test that everything is working properly. We're going to use the dig command on get_t.spatakly.xyz. You can use any of the subdomains, but I'm just choosing get_t because it's the first one that we're going to work with. Once we do dig, you can see here in the answer section that it points to .210, which is perfect. That's exactly what we want. This domain is set up in what's called a split horizon. That means the same domain name has different answers depending on where you're asking from. My home network gets the internal IP address, but the rest of the internet sees the real DNS record with no conflicts. Now, before we can create the ingress, get_t needs to know it's running behind a reverse proxy. Without this, clone URLs, redirects, and webhooks will all reference localhost port 3000 instead of our domain. So let's go ahead and update our get_t deployment and add these environment variables. The first one is get_t server domain, and that's domain is get_t.spatakly.xyz. The second one is get_t server root URL, which again is http://get_t.spatakly.xyz/. The third one is get_t server reverse proxy limit is 1. And then the last one is get_t security reverse proxy trusted proxies. And we're going to set that to the entire 10.0.0.0 address space, just because it's easy. Now we're using HTTP here, and that's fine for internal homelab use, but because spatakly.xyz is a real domain that I own, we can get an actual Let's Encrypt certificate for these internal services, even though they're not publicly reachable. But that's the next video, so stay tuned next week for when we update this from HTTP to HTTPS. Then we apply and roll out the change. In my Proxmox home lab, I had to configure special header handling for get_t behind Traefik. The same applies here. Get_t needs to trust the forwarded headers from Traefik, otherwise it thinks it's being accessed directly and generates all the wrong URLs. Root URL is the critical one. Get this wrong and your clone links and redirects will all point to localhost. Reverse proxy trusted proxies tells get_t which IP addresses to trust headers from. We're using the entire address space of 10.0.0.0 to cover the whole home lab, including Kubernetes pod IPs. And now for the main event. This is the get_t ingress controller. The ingress controller is just a YAML specification that points get_t.spatakly.xyz into the get_t port 3000 address inside Kubernetes. Now we want to apply the change using kubectl apply -f get_t-ingress.yaml to apply the change, and it's been applied. Once it's been applied, let's go ahead and check the dashboard again to see our route appear in the Traefik dashboard. You can see there's now 6 successful routes, and if we click on the routes, you can see the new one of host.get_t.spatakly.xyz here. First, let's test it with curl to make sure everything works. So curl http://get_t.spatakly.xyz, and our home page will come up, as you can see here. Next and finally, we're going to open it in a browser. http get.t.spectacularly.xyz. The browser is going to complain that we're not over a secure connection, but that's okay for now. We're going to change that next week. Log in and go to the code section for repository Kates, and you can see that the address is get.t.spectacularly.xyz. Everything is working now. Let's expose Grafana next. Grafana doesn't need the trusted proxy configuration that Get-T did. It's more forgiving about headers. The one thing worth setting is root URL, so Grafana knows its public address and redirects correctly after login. Unlike Get-T, where missing this breaks things visibly, Grafana might appear to work without it, but subtle redirect issues can come up later, so we'll set it now. Now to set this, we want to use Helm upgrade on the Kubernetes stack, including the values that we just set for monitoring-values.yaml. Of course, it helps if I spell namespace correctly. So let's go ahead and change that and hit run again. And now the Kubernetes stack is updated with the new values. Let's test it with kubectl get ingress and see if our ingress controller is working. And sure enough, the address is pointing to .210 for grafana.spectacularly.xyz. So we're ready to test this in a browser. And in the browser, we go to get grafana.spectacularly.xyz, and we get complaint that it's not over a secure connection, and Grafana comes right on up. Everything is looking good so far. Let's take stock of what we built. In the beginning of this video, we had to have a console for each Get-T and one for Grafana, port forwarding the port from our local machine to the Kubernetes cluster. Now what we have is we have MetalLB sitting there holding 10 IP addresses on our network to give us bare metal IP addresses so that we have something to point an IP or a DNS entry at. On our local DNS, we have spectacularly.xyz, now wildcard pointing to this MetalLB IP address. The MetalLB IP address then points to our ingress controller, which is Traefik. And Traefik takes the URL, breaks it up, and says, okay, Get-T, you go to this port 3000 over here. Grafana, you go to port 80 over here, and we get the pages that we want. Now, HTTP works great for internal homelab services, but it's not the best. So next time we're going to look at adding in HTTPS and TLS. Browser trusted certificates so that we don't get that message saying, this is untrusted, are you sure you want to continue? So that's the video that we're going to do next. So please stay tuned and subscribe and ring the bell so you're notified when the next video comes out. And while you're down there, hit the like button. Give us a comment if you have any questions about this or any of the videos in this series. And we will see you in the next video. Thanks for watching. Bye.